to all?
Yes, sir.
Muskan, actually it was wrongly posted on your group. It is a 8th semester class, right? Already I have deleted this one, so you can read from here. Today morning I have taken your classes, na? Hello? Am I audible?
You are audible.
Actually, it was wrongly posted on your group. Actually, it is the 8th semester class, so you can read from here. I have already deleted the message from your group, right? Okay, so you can read. So here we can wait for some minutes to join others. If not, then we'll start our class. I'm just sharing my screen to all of you. We'll just wait for 1 and 2 minutes to join others. If there is no student, then we are starting our program. So today we are going to learn the graphical method of solution of game theory. So game theory, using graphical method we can solve the game theory also. So we are going to start our class. It is the graphical method to solve the game theory. So today we are going to learn the graphical method of game theory. How to solve any game theory problem using graphical method. So we are considering one pair of matrix. So this one is B1, B2, B3, B4. It is the player B, and here it is the player A. It is A1 and A2. One 302, row wise 1302, then second row 301 minus 1, 301 minus 1. The given game, we have to solve this by graphical method. So solution, we are starting the solution. The given game has no saddle point. So is there no saddle point? So this game is the mixed strategy. suppose A choose A1, A choose A1 and A2. A choose A1 and A2 with probabilities x and 1 minus x. With probabilities x and 1 minus x. So A choose two strategies, A1 and A2. Probability of A1 is x and probability of A2 is equal to 1 minus x. If B chooses B1 along with this, B1 along with this, then the expected gain G of A, expected gain, if we say that expected gain G of A is G equal to, what is the value of G? G equal to x plus 3 into 1 minus x, 3 into 1 minus x, that is 3 minus 2x, 3 minus 2x. If we draw a graph, of this function showing G against x, showing G against x, we notice that by choosing B1 throughout, we can restrict its gain, to lie on the line G equal to 3 minus 2x. We compute similarly, the other gain of A, when B uses B2, B3 and B4, B2, B3 and B4. One is getting that G equal to 3 minus 2x when B playing B1, when B playing B2, then also we got another line, when B plays B3, then we got another line, when B plays B4, then also we get another line. So there are 4 lines will be there, and there the lines are G equal to 3x, this one, as well as G equal to 1 minus x, g equal to 1 minus x, and the last line is g equal to 3x minus 1. G equal to 3x minus 1. So there we got the four lines. Number 1, if we say that this is the g1, this is the g2, this one is the g3, and this one is the g4. Then g1 equal to 3 minus 2x, g2 equal to 3x, g3 equal to 1 minus x, and g4 equal to 3x minus 1. So there are four strategies of B. We got the four line A's gain, line of gain of A. We got four lines. We draw two parallel axes, 1 unit distance. Now we draw two parallel axes, two parallel axes, 1 unit distance, 1 unit distance, 1 unit distance apart, and mark a scale on each. The two strategies A1 and A2, the two strategies A1 and A2 of A represented by these two straight lines. So we have to go for the next slide. Here we are choosing two parts of that. Now we have to draw the lines. here we are making the two straight lines, A1 and A2. This line for A1 and this line for A2. Yes, so it will be given that this one minus 3 minus 2 minus 1 0 1 2 3 4 5. Here also this 5 4 3 2 1 0 minus 1 minus 2 minus 3. This is the technique. Now we are taking the line of, this is the gains. Now here we are taking the line L1. It will be, L1 means G equal to 3 minus 2x. So it will be coming from 1 to 3, L1, 1 to 3. So 1 to 3, one line is here, that is L1. And L2 is equal to 3 to 0. L2 will occur from 3 to 0. This is the L2. Now L3 is equal to here 0 to 1. That is the value of L3. And L4 is equal to minus 1 to 2. Here is minus 1 to 2. This is the value of L4. This one is the L4. Now if we make the line of intersection here, so this is the maximum bold line, that is the maximum here to here. So there is a maximum. So this point is the maximum. This is the maximum point. Right, so here we can go for the explanation of this. Okay, so for the explanation we can write down here 0 0 equal to 1 unit. Sorry, here it is 0 0 is equal to 1 unit. This is the initial line. This is the initial line. The gain lines L1, L2, L3, L4. These are the gain lines L1, L2, L3, L4. Are then drawn to represent the gains of A corresponding to B1, B2, B3, B4. Corresponding to B1, B2, B3, B4 respectively of B by joining 1302 on the line representing on the line representing A1 with A1 with 301 minus 1 301 minus 1 on the line representing A2 Look at here, 0 0 is the 1 unit, 0 to 0 1 unit distance, and that is taken as the initial line. The gain lines are here L1, L2, L3, L4. These are the gain lines drawn to represent the gain of A corresponding to B1, B2, B3, B4 respectively of B by joining 1302 on the line representing A1 with 301 minus 1. That is, these are the points for first one 1302, that is the 1, then 3, then here it is 0, it is 2 with the 301 minus 1, 301 minus 1. That means L1 lines 1 2 3. So 1 2 3 means the L1, this is the L1, 3 to 0, 3 to 0, that means the L2, 0 to 1, that is the L3, and 2 2 minus 1, that is the L4. That is drawn here. Now in order to find out the point, in order to find out the point which will maximize the minimum expected gain, which will maximize the minimum expected gain of B. That means actually we are finding out the maximin. We bound the figure so obtained form below by drawing a thick line, That means this one is the thick line. This is the thick line which we have drawn as the maximum. The highest point M within bracket maximum highest point capital M of this bound so we can write down this is the capital M. Capital M refers to the maximum of the minimum gains. maximum of the minimum gain. Maximum of the minimum gain. At this point, as it obvious, as it obvious, B has used his course of his two courses of action, and there B3 and B4, and B4, as it is the point of intersection, as it is the point of intersection, as it is the point of intersection of L3 and L4, Look at here, the point of intersection of this is the L3, and this was the L4 and L3. The point of intersection is capital M. So this L3 is corresponding to the B3 and L4 is corresponding to the B4. So from here we can find out this bound. At this point, as it is obvious, B has used his two courses of action and they are B3 and B4. Because of that, the B3 represents the line L3 and B4 represents the line L4. There the cutting point or intersection point of L3 L4 is capital M. So this is the courses of action. Therefore, the 2 cross 2 submatrix. So we are going for the next part. Therefore, the 2 cross 2. Therefore, the 2 cross 2 submatrix which provides the optimal solution of the given game is shown on the right. Shown on the below. So that is here it will be coming right like that. The 2 cross 2 matrix should be like that. Plus 2 matrix is 0, 2, and here it is 1, minus 1. This is for B3 and this one for B4. And courses of action of A is A1 and A2. Now solving as usual. This 2 cross 2 subgame we get x equal to half. So 1 minus x is equal to 1 minus half is equal to half. The probabilities of B3 and B4 are the probabilities of B3 B4 are B3 and B4 are computed as 3 by 4 comma 1 by 4, 3 by 4 comma 1 by 4. The value of the game is, the value of the game is half, as x equal to half is given. Thus the optimal strategies of A, thus the optimal strategies of strategies are for A half comma half, and for B there are only the B3 and B4, so B1 0, B2 0, B3 equal to 3 by 4 and B4 equal to 1 by 4. This is the optimal strategy, and value of the game is equal to half. Is it clear? So I think there is no student, so we could not got the answer from here, so it is clear to everybody. We have to take that solution. So overall, if we go for that, then we got, so from the first, once again we are recap the given problem. Look at the first slide. If we recap the first problem, it is given that the optimal strategies of A and B, there are payoff matrix of the game theory is given. For the B, there are 4 strategies, B1, B2, B3, B4. And for A, there are 2 strategies, A1 and A2. So, here for A1, it is 1, 3, 0, 2 corresponding to B1, B2, B3, 4 and B3, B4. And strategy A2 is 3, 0, 1, minus 1 corresponding to B1, B2, B3, B4. Now we have to solve this payoff matrix of game with the help of graphical method. So the given game has no saddle point, because of that there is maximin and minimax are not equal. So we cannot say that there is a maximin and minimax are different, so there is no saddle point exists. So their mixed strategy will be taken. Suppose A choose A1 and A2 with probabilities x and 1 minus x. A choose A1 with probabilities x and choose A2 with probability 1 minus x. If B choose B1 along with this, then the expected gain G of A is, B choose B1, then expected gain should be for B 1 into x, and for A2 it is 3 into 1 minus x. 1 into x, G is small g equal to 1 into x plus 3 into 1 minus x. Because of that, for A2 probability is 1 minus x, and for A1 probability is x. So 1 into x plus 3 into 1 minus x, that is coming 3 minus 2x. If we draw a graph of this function showing g against x, we have plotted one graph that is g against x. We notice that by choosing B1 throughout, B can restrict its gain to lie on the line G1 is equal to 3 minus 2x. We compute similarly for the next one for B2, then it will be coming 3x, only 3x. For B3 it will be 1 minus x. For B4 2x into 1 minus x into minus 1, that is minus 1, that is 3x minus 1. So there are 4 lines will be coming here, g1, g2, g3, g4. If we plot this against g and x, we draw two parallel axes 1 unit distance apart and marks a scale on each the two strategies A1 and A2 of A respectively by these two strategic lines. So A1 is the here we are marking two strategic lines A1 and A2 for A. Now we are going to, it is shown in the next part. So we are going through that one. Look at the next slide. Here we are taking for A1 this straight line and this straight line for A2. Now here we are making the scale, that is 0, minus 1, minus 2, minus 3, and in upper half 1, 2, 3, 4 up to 5. Here also A2, and distance between this 0 and 0 is 1 unit. That is 1 unit in this initial line. This is called the initial line. The gain lines L1, L2, L3, L4. Now look at the previous cell, for the first cell. Line of action for this A1 for B1, that is 1, 3, 3, 0, 0, 1, 2, minus 1. So look at here. One three is plotted here, that is L1. Then L2 means the 0, 3. Then L3 means the 0, 1, and L4 means the 2, minus 1. These are the line. The line cutting L3 and L4 at this point, which is the peak point of this, that is called the maximin. Look at here. The gain lines L1, L2, L3, L4 are then drawn to represent the gain of A corresponding to B1, B2, B3, B4 respectively of B by joining 1, 3, 1, 3 is the L1, 3, 0 is the L2, 0, 1 is the L3, and 2, minus 1 is the L4 on the line representing as A1, on the line representing as A2. Now in order to find out the point which will maximize the minimize expected gain of B, we bound two figures. So obtained from below by drawing a thick line. Here this is the thick line, this is called the maximin line. The highest point M, that is the maximum of the minimum. Highest point capital M of this bound refers to the maximum of the minimum gain. At this point, as it is obvious, B has used the two courses of action. Because of that, this point is the cutting point of L3 and L4. So here only L3 and L4 is act. L1, L2 is not acting here because they remain indifferent. Because of that, this cutting point capital M is the line cutting through L3 and L4. They are the intersecting point of L3 and 4. And L3 means the B3 and L4 means the B4. L3 is the line which represents the strategy B3 and L4 is the line which represents the strategy L4. So we can say that this point is the only B3 and B4 are involved. So B1, B2 remaining unchanged, that means they are going for the 0. It is the point of the intersection of L3 and 4. Now we have to go for the next slide where it is given. Now look at here, therefore the 2 cross 2 submatrix only B3, B4 and A1, A2, that is this. The optimal solution of the given game is shown in the below. Okay. So from here we are taking that this one x equal to 0 into this plus 0 into this, that is x equal to half and 1 minus x equal to 1 minus half, that is half. The probabilities of B3 and B4 are therefore 3 by 4 and 1 by 4. the value of the game is equal to half. Thus the optimal strategies are for A equal to half half and for B equal to 0, 0, 3 by 4, 1 by 4, and value of the game is equal to half. Because of that, here when we are getting the cutting point of L3 and L4 line, here the cutting point of L3, L4. Now L3 is associated with B3 and L4 is associated with B4. So only in course of action B3 and B4 will be coming. Otherwise this B1 and B2 remain unchanged, so they are remain indifferent. So they are not coming into the course of action. That means they should put as the zeros is the strategies, and obviously the probabilities will be 0. Actually we know that the sum of the all probabilities is equal to half for strategy A. That is the summation of A1 plus A2. A1 equal to half plus A2 equal to half equal to 1. That is the summation of probability. Summation of all probability. We know that summation of all probability obviously 1, and same thing strategy of B is equal to summation I equal to 1 to 4 BI, that is equal to B1 plus B2 plus B3 plus B4 is equal to B1 is 0, B2 is equal to 0 plus B3 is equal to 3 by 4 plus B4 equal to 1 by 4. Then it is 3 by 4 plus 1 by 4, that means 1. That is also the summation of all probabilities. So thus the game is optimal, what we have found here. So the for mixed strategies, here A choosing the strategy A and A1 and A2 with the A choose the strategies A1 and A2 with the probability half and half, and B choose the probability strategies B3 and B4. So the probability of B1 is 0, probability of B2 is 0, and probability of B3 as the 3 by 4, and probability of the B4 is 1 by 4. Then the value of the game should be coming as a half. That is the optimal solution. So for answer we can write down A equal to half comma half, B equal to 0 comma 0 comma 3 by 4 comma 1 by 4, and V, that means value of the game, is equal to half. Thus by this method we can find out the solution of any kind of the mixed strategy or any kind of the pure strategy by this graphical method of solution. So that's end our problem, that is the as well as the method of game theory solving by graphical method. So for today the class is end. Thanks to everyone.